So now continuing with our exercise of cleaning and processing data, once we uploaded a script, we have to verify that we've installed the packages correctly. Now we're going to use these 5 packages. The string gr will allow us to process the data that have text and characters. This will allow us to use high caps, low caps, and group some categories that could have any problems in the database. Deblayer and tidyverse will allow us to manipulate the tables. And whenever we're going to do any updates in each one of the variables. Lubridate allows us to manage information from the dates specifically. In our database, we have the sowing and harvest dates, so those can be processed with this package, and ggplot will allow us to generate graphs. So we're going to upload them here. And right now we're going to read the database. We can see that this didn't generate any errors when I uploaded the packages. So in case that I had an error, I hit install and then I have to upload the pending package. Or if you have a problem with the R version, you can also download it and install it. Okay, now we're going to use the database. So let's write base de datos or database for maize. I'm going to use the read.csv. We can also have the version 2 in case we separate it in period and comma. If I open the quotation marks here and I press tab, I'm going to see the list of the files that are contained within that folder. So let's say that I want to read this database, dataset Maize Cordova. So right now I'm just going to read. Control Enter. So the database uploaded here. So what I'm going to do now is to explore the database with the basic functions that R has for verifying that the database was correctly read for the first time. So we have the str that allows us to see the summary of the database very fast. And this shows us a result that's very similar to the data dictionary. It tells us what are the variables and what type of characters and numbers. You have the ID, the seeds that are used in the sowing density. So we can see all this information here. And apparently we don't have any errors just by going over it. We can also use the summary function. This gives us a little bit more information. It summarizes the values of every variable. And what we have here is that these variables that are categories, unfortunately, they're not showing us the description. So the idea would be to see the frequency. So what I can do now is to have another function here from read.csv for those streams to be read as factors. This is an object in R that you can assign classes to each one of the categories. So these classes allow us to visualize in a summary each one of the different categories. We just have to add an argument here. I'm going to use a comma and then go down here so we can see the whole screen. So this is the command string as factors. Then we press true and I execute it once again. And I'm going to do the summary again. It hasn't been updated yet. But the thing is that I had already uploaded a file that's called base de datos or database, so I didn't read the current database that I need. So this is the database that I need for maize. I was reading the wrong file. It was uploaded from before. So now we can see more details of each one of the variables. and we can begin to think about a strategy to correct the problems of the database. In order to begin and design a revision strategy for this database, and also to follow up the different actions that we execute from this moment on, I would recommend you to do the following procedure. First, we have to create a new file. We can go back to the database for the project. So we should always create a CSV file. We can save it with the name. And then we can begin to define a procedure for each one of the variables that we're going to revise. In this case, we can use the same data dictionary for capturing the names of the variables. So I'm going to use them in this new database that I opened here. So right here, I would put the name of the variable. And I even left the ID here. I'm going to add it here. So I'm going to define an action that I'm going to carry out based on my revision. If I'm going to keep it or I'm going to remove it. And I'm going to use another column for observations. As I told you before, I'm just going to tell you what's a strategy that I'm using while I revise the database. This has helped me a lot to discuss with the other people that helped the creation of the database whenever I find any errors. But every data analyst can define the strategy that's more convenient for the person. Probably this is not the most effective because it has many variables, and probably the revision would be very long with this strategy. Nevertheless, the important thing is to leave some traceability of all the actions that are carried out from this moment on. So what I'm going to do right now is to save the file. I'm going to save it as a CSV so that we can read it from R afterwards. So the name would be Revisión Base de Datos, or Database Revision in English. And then I can go back. What I'm going to do in order to facilitate that processing, let's see if I can accommodate the console and also the revision in the screen. And what I do is this: if you click in the window, and you will probably want to relocate, you hit the start button in Windows, and you choose the place you want to locate it. So you can choose the right side of the screen, so it'll fit it right in there. And then I can start to see my console, and at the same time I can see the spreadsheet where I'm taking my notes. Whenever I do this, my terminal gets disorganized, but I can readjust it so that I can have a better view, and I can generate the summary once again. So I'm going to do first revision of the database. So I'm going to go and revise it one by one. So I see the ID here. Apparently it has no problems. And it's always important to keep it there. So I'm going to use the action that's called maintain. This farmer variable, farmer mail, farmer address, all these variables, the idea is not to keep them after the analysis, or before the analysis, I'm sorry. So we can use the remove function. Then the date, the planting date, the harvest date, You can see it on the month, day, and year format, but are still recognizing them as categories because we have the number here. When they're recognized as dates, R shows us a minimum and a maximum and an average of the dates, approximate mean date. So we have to choose a procedure. First, we have to transform the date to the format that we need. So we have to write transform format, transformar formato. And not only transform the format, I also want it to convert into a variable that I can analyze afterwards. So I'm going to say that planting day has to be transformed into a day of the year. I don't want to keep the natural format of date in my database. And the same thing over here, transform format for the harvest date. And with the harvest date and the planting date, I would like to calculate the duration of the cycle. Duration of the cycle. I wrote this here, but the idea is for this to be kept as an observation, not an action. And I'm going to define the action now. So once I do this procedure that's on the side, the idea is for us to be able to use the remove function, because I'm not going to keep them afterwards, because once I do this procedure that I used here, the idea is for them to be removed. Let's see the other variables, sowing seed numbers. Apparently there are no mistakes here. These are numerical values and they're being recognized as numerical values. It has some NAs. I could also take decisions over here if I wanted to remove variables, because they have many missing data. But this is not the case because it only has one NA, so I could process it with one of the methodologies that we're going to see in a few minutes. Plant density. Up to this point, I wanted to keep all of them because I had not identified any error or mistake. And these are important for the analysis that I'm proposing, which has to do on how to explain how certain factors or management factors like climate and soil are affecting the yield. What I was able to identify here is that there's an atypical value. And we had an additional 0 here. We're probably going to see more of this when we're inspecting the values, but I can add a comment here. Revise a typical value. And then I continue with my inspection. Let's see, fertilization, chemical treatment disease, other treatments. Apparently, there are no further mistakes in this first inspection that I'm doing with the summary. And these are numerical variables, and R is not generating any error. So I'm going to tell you what are the actions that I can take here. Solar radiation, I don't see any problem here. So far, we don't have any more mistakes. This is the number of technicians. The number of technicians, this could not be that important. If I consider that it's not important, I can say I can remove it here. So I'm going to keep all of these variables. I'm going to maintain all of them. And apparently the number of technicians was not included in the dictionary in the beginning. Or it's further down here. Very well, so I'm going to keep all of these because I didn't identify any problem until number of technicians. I'm not going to keep it because I don't think it's a relevant variable. It might be very relevant for another function, but I don't want to keep it here. I'm going to assess other factors instead of this one. Now we can go to the qualitative variables. they can have some inconsistencies that we have to revise. So what we're seeing here is that there are some high caps and some low caps. As far as there are no categories that are similar, but are duplicated because they have been miswritten, there's no problem. But the ideal situation would be to be able to standardize everything to high caps or low caps. This would be the sowing. Right here in informer crop, we can see that some of the categories have a very low frequency, like beans, grass, and cassava, and some NAs. The most important thing here would be cotton and maize. In variables like this one of the options that we could decide on choosing would be to create another category that's called others in order to not see these variables that have such a low frequency, and they're probably not going to be representative for the analysis, and they're going to delay the model. So in this case, this is a variable that I want to maintain, just like the others, but I'm going to say that I want to transform it, and I'm going to group it in other categories different to cotton and grass. So I can continue my revision. This has no problem. This variable has a problem. We can see that we have high caps mixed with low caps, variables that are miswritten, mecanizada with a double A. So right here we have to identify an alternative in order to correct these typos. So up to this moment, I would like to keep all of the variables, but in harvest method, I would like to do a revision. So I write here revise values and typing problems. So let's continue with the type of crop. So I could transform this into others category, but there are very few observations. So what I can do here is to decide and choose hybrids, to maintain hybrids, and OGMs. So I'm going to say that I want to filter and only keep hybrids and OGMs. The same thing applies with this variable called soil structure and runoff. So I'm going to add some additional steps here. For example, I'm going to filter remove values with moderate runoff. It will be just one. I'm going to add a comma here in order to keep this in a more organized fashion. So runoff would be down here. Soil structure, the same thing. I'm going to remove everything that's called suelta o polvosa. The texture does not have any inconvenient. I could also explore this category called others. I cannot see all of them right now. to decide if we have to carry out any modifications, to see if we have to group them and remove them. We're not going to do that on the meantime. In this category called departamento or department, all of them have the same classification. So let's say that we're talking about the Cordoba, and that's a department. And this is a department, a variable that we can remove because it does not give us any additional information to explain the yield. So I could remove this one, and we can maintain the others. Yield, obviously, we have to keep it. But it appears that there's an error with yield. This is shown as a category. With this column tells us that category 4 has 44 repetitions, category 5 has 42, and so on and so forth. And this should be a numerical variable. If there's not such a big database, I could explore which values could be generating this problem with the yield. So let's revise. I don't see any inconvenience so far, unless there's one. I see that there's a problem here with the comma, with the decimals. I only see a comma here. So we also have to take an additional step here to transform this numerical value. And I have to transform or replace those commas for periods. And transform two numerical values. So I'm going to save this. And in the next video, we'll define how we can execute each one of the actions that we've planned here in R.